Okay, so this video is going to be about force diagrams. Now, I've drawn these on the board before, but what it is just a drawing that kind of attempts to look at all the different forces acting upon an object. So, for this example, I've got a book on a table, okay? So here's my book, right? Here's the table. And what I'm trying to do here is draw the different forces involved here to try to kind of make understanding of that. So the most obvious one is here, which is pulling straight down. That's the force of gravity. Okay, so we call that Fg. It's force gravity. That's gravity pulling down. Now, because it's on a table, there has to be a force pushing the other way, and it has to be equal or greater than the force pulling down, right? So, and we call that the normal force because we don't have a better name for it. So in this case, because the book's on a table, it's not moving, it's not falling, because the table is pushing back, right? So gravity, kind of on this one here, is pulling. It's pulling it down, right? And the normal force is pushing with equal force, okay? I say with equal force because if it was pushing back somehow, that book would go, it would move up. It's not doing that, so it's pushing with equal force, okay? Right, so for this diagram, that's really all we need to talk about because that's all that's kind of really happening here. Now I put a couple of things here, right? So the normal force is a push of the table against the book, okay? So it's against the book, so it's pushing back against the book. Gravity is the force of gravity pulling down, right? And that's pulling it down technically to the center of the earth or until it hits the ground. Now, in this case, these arrows are drawn as equal, okay? So if the forces are equal, the arrows should be equal. So because this book's not moving, the arrows are equal, okay? So the arrows, don't forget, they show the direction of the force, okay? So in this case, pushing down. And the larger the arrow, the longer the arrow, the larger the force. So for example, this is a small force. This one with the longer arrow is a larger force. All right? So keep those ideas in mind, right? Equal number, arrows should be equal, means the forces are equal. The direction of the arrow shows the force. And smaller ones is a small force. And a large arrow is a larger force. So let's take this example. We've talked about this before, right? So here's a car going down a ramp. This was an experiment we did, right? Now, the force of gravity is pulling straight down, right? And that's causing, well, it's pulling down, right? And we have the force normal, which acts perpendicular, right? So this is perpendicular to the ramp, okay? So it's kind of walk at a funny angle there, okay? So it's perpendicular to the ramp. So right there you form a 90-degree angle, for example, okay? The other one is a force of friction, right? We just call that little f. You could call that big F, little f, that's fine. But it's pulling the other way, right? So it's pulling against the way the car wants to go. So friction generally, when friction slows things down, right? It moves against the direction. So what you end up with is kind of the force net, the net force is a movement this way, okay? The car moves down the ramp. And that's because of gravity, right? Gravity pulls the car down the ramp because of the incline. So notice this arrow is the biggest arrow, so that's the force there. Gravity and force normal are equal, but the force of friction is smaller because the car is going down a ramp, right? So it's moving this way, so friction works opposite the movement, all right? And kind of the final one, this introduces this idea of tension, okay? Like if you've pulled tight on a rope, you've experienced tension, right? So this is a weight or a mass hanging on a string, okay? So let's correct that. but it's hanging on a string. Okay, so here's the mass, right? And here is the string. Okay, so notice the mass isn't falling, it's just hanging. So there's a force, the tension, force of tension, so Ft, is pulling opposite gravity, right? Gravity's still pulling down. Gravity's always there when we're on the Earth. So it's pulling down, and the tension is pulling it the other way. Now, because the mass isn't falling, this and this are equal. So those arrows have drawn as equal, right? The tension arrow, this one, is the same length as Fg, so the weight does not move. So it's hanging there, right? Okay, so hopefully this gives you an idea of how to draw these, okay? And the arrows that we draw, because the next bit is you're going to practice drawing some force diagrams, okay?